Today we're going to work on solving equations with like terms. Now you might be asking yourself, what is a like term? We'll answer that in just 1 minute. I want you to remember from last time our two-step equations. Remember that we had to take care of all constants before we started thinking about any coefficients. They've got to be in that order or else we don't get the right answer. So today we're going to add a third step to solving equations called combining like terms. You've done like terms before. Like terms, remember, are terms with the same variable that can be combined. We're going to do a quick review of what a like term is. For instance, what of these following terms can be combined? How about 3x and 4x? Can they be combined? Sure. I have 3 x's, I'm adding 4 more x's. That gives me 7 x's. How about 8x minus 2? Can those be combined? No. Remember, they have to have absolutely identical variables or both be constants in order for them to be combined. So these cannot be combined. How about 9k and 5w and 8? Are any of those like terms? Do any of them have identical variables? Nope, there's nothing here that can be combined. How about negative 10r plus 6 plus 4r? Sure, I've got an r term and another r term. I've got negative 10 r's, like I owe somebody 10 r's, and then I'm getting paid 4 r's, or adding 4 more r's. Together, that's going to give me negative 6 r's. I can't forget this plus 6, even though he doesn't have anything to be combined with, he still gets included in my answer. So I get negative 6r plus 6. Up here in my fifth example, I have a negative 4m and I'm subtracting an 8m squared. Even though these are both m's, one has an exponent of 2, the other one does not. That makes them not like terms. I cannot combine those m's. In example number 6, I have 2y minus 7 minus 3y. I have a y term with no exponent, or you can think of it as an exponent of 1. I have another y term with no exponent or exponent of 1. I have 2 y's. Remember that this minus sign goes with the 3y. The sign in front of a number stays with the number. So really I have 2 y's and I'm subtracting another 3. That gives me negative 1y, or I can just write it negative y, and I still need to include that minus 7 in the middle. Example number 7, I have 6ab minus 9a. Do these have identical variables? No. One has an a and a b, the other one only has an a. So this is another case where I cannot combine those terms. And finally, number 8, 5 minus 2 minus 3p. My constants are still considered like terms. So I have 5 minus 2 gives me 3, and then I'm subtracting 3p. In an equation, we must combine like terms before we can continue on to constants and coefficients. So when I solve this equation 4x plus 5x plus 6 equals 33, I have to look on this side and I can see that I have like terms 4x and 5x. I'm going to go ahead and add those together to give me 9x. I still have a plus 6 and I still have an equals 33. Now I can take care of my constant, then my coefficient. My constant is this plus 6, So I'm going to subtract 6 from both sides, of course. Those cancel. And I get 9x equals 27. Dividing by my coefficient, 9 over 9 goes to 1. And I get x equals 3. This is my final solution. I have another example, 7 equals 4m minus m minus 5. Do you see any like terms? We do have like terms. They're on the right-hand side of the equation this time. Totally doesn't matter. I can still combine them. I have 4 m's and I'm taking away how many more m's? That's right, I'm taking away 1 m. Together, those are going to give me 3 m's. Since these are the only two terms I used, I have to write down everything else that I didn't use. Now I can start my constant and coefficient steps of my equation. Where is my constant? Negative 5. What's the opposite of subtracting 5? Add 5. I'm going to do that to both sides of my equation. Minus 5 plus 5 cancel. And I get 12 equals 3m. Dividing by my coefficient of 3 gives me 4 equals m. That's not how I want to write my answer, however. Remember, we always want to leave it with our variable on the left. Finally, we have 5a minus 4 minus 3a equals 44. Do you see the like terms? 5a and minus 3a, of course. How many a's am I going to have left over if I have 5 a's and I'm taking away 3 a's? I'm going to have 2 a's left. I'm still going to write down my minus 4 that I haven't used and my equals 44. Now I'm ready to take care of my constant. And finally divide by my coefficient. A equals 24 is my final solution. Remember to ask questions if you're not understanding. We have lots more examples that we can go through if needed. Your assignment today is a Solving Like Terms Equations worksheet. Good luck!